Here we go. Alright, so I'm gonna try to do this. This may work, this may not work. So okay. So I'm gonna understand how this problem works right now. And we're gonna record myself so that I can look back at my thinking process, and also maybe this will help somebody else. So let's see. So the first thing I'm gonna do is, this is basically an edit distance problem. So this is the code that I've already created, and this code is mostly created, I guess, by figuring out the recursion cases and so on, and just doing that, and then saying, oh, filling in this memoization table. Like, it just made sense to do this and to do this. But how is the table actually being filled in is now what I'm going to try to figure out. So this will be my first time doing this, so this could fail utterly. So what I'm going to do is let's see, so the table will be, I'm going to take the example here, dog and frog. So dog and frog would make where is it easier? Is it easier to do it here, or is it easier to do it here? Let's see, I can do it here. I can do 0, 1, 2, and then we'll go 3. 3, so basically we're gonna have 4 rows, so we'll have it for each one. So the idea is this, is that if I equals 0, string 1 is equal to dog. If I is equal to 1, string 1, we're taking a substring, and it'll be dog. If I is equal to 2, string 1 is equal to G, and then basically just finishing out the whole idea. If it's equal to 3, we basically are get to the empty set, empty string. So that's saying that. Now I need to do over here, we go from 0 to 1, 2, 3, 4. So we'll go 4 because the length is 4. So similar premise. So I think, so what would be the first thing that would happen in my recursion? So it starts at when I and j are equal to 0, and it's going to call this, right? So if I look up here, it's going to recur. This is obviously going to be, you know, whatever. So the first thing I'll do is it will, well, if they're equal to each other, I guess, it will just do this, which is true. So it will add 0 to whatever the previous is, add 0 to whatever the previous is, and then it's going to go to here, and then it's going to say, okay, let me go the min direction, let me go to I, plus we're going to go to this. So let's consider a couple of cases to fill in the table. So let's say I is equal to 3 and j is equal to 4. So that would be right here, and obviously it's going to be 0 at a distance. There's no edit to be done if they both are empty. Then if we take basically, if we just go through here, let's see, so I think go back like that. So I think these are increments up by 1 each. So it's like here you have to add 1, because this means that dog is an empty string, but j is not an empty string. And then here you would have 2. There you go. I went too much. Okay. And here it would have to be 3, and then here would be 4. And then let's see if I can line those up. Okay. And then for this one, it would be yeah, similar concept. So it'd be 1, 2, and 3. And then if we go to this value, let's say I is wait, what the hell? Idiot! I'm doing I for my row. I should do I for my. Is that a problem actually? That's not a problem. Actually, that's good actually. So I is equal to 2, and let's say j is equal to 3. So that means we're looking at these two strings. We're looking at G and G. So because they're equal, it'll look at the previous value on the diagonal and add 0 to it. So there's no edits necessary here. what if we're here? If we're here, we're looking at if we're here, we're looking at O, G, and G. They're not equal, so instead it'll do 1 plus the min of the surroundings, so it's going to be 1. We'll do it like that, and then this one will do the same thing. It'll be 1 plus the min of the surroundings, which would be 2. Okay, now we go to here, we go to 2 and 2, which is 2 and 2 will be, if I is equal to 2, it's G, and J is equal to 2, it's OG, I think, so it'll just be the min. So let's see here, 1, then we go up. Now for this one, they're going to be equal, so it's going to be 0 plus the min, so it's 0 edits here. And if I go up, they're definitely different here, so it'd be 1 plus the min of the surrounding elements. And then if we go here, it's 2 and 1. I already know they're not going to be equal at this point. We already went past when they're equal, so it's going to be 1 plus the min, so it's 2. This one will be 1 plus the min, which is 1. 1 plus the min, which is 2. 1 plus the min, which is 3. 1 plus the min, which is 2. And wait, what? For F and D, they're not equal, so it'll be 1 plus the min. That would give me 3. Oh, that's the answer though. Okay, yeah, that's the answer, so it's 3. So if I think about this, what it's saying is that the best way to go about this problem is to, let's think, so we start, well, this is just the number of deletions, right? So the best deletion course is to not delete these and this, because you could have 0 deletions at that point. And then you're going to have to make your first deletion, and then you make your second deletion here, and your third deletion here. Now notice that this is, you're going to make 2 deletions of like F and R, and make 1 deletion of D. And yeah, so that's filling the table. That gives a correct answer, because this 3 is the number of deletions, or the number of edits required, the minimum number of edits required, and that's where this min function comes in here. And this min function just looks at its 2 adjacent to the below it and to the right of it.